In this talk, we're carrying on considering the physical properties of the glomerulus that give rise to the process of ultrafiltration. Now, here's the diagram we've been using. We have the afferent arteriole and the efferent arteriole and the glomerular capillaries that we've shaded in red. The glomerular filtrate is forming via this process of ultrafiltration from the blood in the glomerular capillaries through to the glomerular space. Once formed, the fluid is going down into the proximal part of the nephron, the proximal tubule, and that will become the proximal convoluted tubule. So the parietal layer is round about here. This is the parietal layer of Bowman's capsule, and the visceral layer is actually a layer of specialized cells called podocytes that surround the individual capillaries that make up this ball of capillaries called the glomerulus. Now, of course, the real glomerulus looks a lot more complicated than my simplified diagram, but you can see here that we've got the individual capillaries of the glomerulus. So let's think about the arrangement of the podocytes around about the glomerular capillary. So here we have the glomerular capillary. Now, the podocytes always remind me of octopuses, or octopi, whatever the plural is. You've got a middle bit and tentacles coming off, but the tentacles are called pedicles, the feet-like processes. So this is the glomerular capillary, looking at it from the outside. And here we have a podocyte just here with its nucleus. And the podocyte has got several branches coming off it, but we'll just consider one. These branches are actually foot-like processes, the pedicles. And that's going to wrap itself around the glomerular capillary. And as it does so, it gives off side pedicles, smaller branches. So it's like this. So here we see the pedicles, the foot-like processes coming from the master cell, as it were here, the podocyte. This is the podocyte. And it's the podocytes that form this visceral layer immediately around about the glomerular capillaries. But there's many of these podocytes. So here we have another one just here, another podocyte, and again we've got the small foot-like process, the pedicle coming out from it. And again, this forms pedicles like this. And we can see that the pedicles from this podocyte here are neatly dovetailing in, leaving small gaps. So if I colour in this one here, this is the pedicel of one podocyte there, and the other one there. And then this is the next one, the one we drew first. I think what you can see now is we've got small gaps between these foot-like pedicle processes. So here we've got the small gaps. I'm just going to colour in blue. Small gaps between the cells, or between the pedicles that are projections from the cells. And these small gaps here are the actual filtration slits. So it's just like a sieve. It is a physical process of sieving with these little gaps, these little filtration slits between the pedicles of the podocyte. And the gaps between the individual pedicels are only about 40 nanometers. Tiny gaps. So you can see that little things could fit through here, but it's going to be a process of ultrafiltration on a very small scale. And it's a bit like this tube I've got here. If we imagine this tube is the glomerular capillary, and my hand is a podocyte with one lot of branches going around there. The other hand is another podocyte, and then between the two we're going to have these very small filtration slits between the pedicles. So any glomerular filtrate that forms has to go through these filtration slits. And the filtration slits themselves are covered with the slit membrane. So we can really see there the physical basis for this sieving, this ultrafiltration process that's going on. And maybe just one more diagram to explain this. Again, we've got the glomerular capillary. And now we're looking at a cross-section of the capillary, and this will be the basement membrane here of the capillary of the glomerulus, and the vascular endothelial cells inside again are almost finger-like. There are projections from the main body of the cell, and that means that between the gaps in the endothelial cells, or between the gaps in the components of the endothelial cells, there's going to be these small gaps here, the fenestrations. So these are the cells of the vascular endothelial cells, or the vascular endothelium, lining the inside of the capillary. Then we have the membrane there. These are the fenestrations, the gaps are the fenestrations, right at the bottom. The gaps are the fenestrations, and here is the lumen of the capillary. Now we know the podocytes are external to the capillary, forming the visceral layer. So here we have a podocyte, and we know that these foot-like processes, the pedicles, go down. And again, if we're just drawing this in section, we'll see it looks like this. So here we have a pedicle, and here we have a small gap. And the gaps between the pedicles are the filtration slits. Same there. So again, just darkening in the foot processes. This is the podocyte here with its nucleus. So these gaps, this gap here, between two pedicels, between two foot processes, that is the filtration slit, that tiny slit there. And we know the slit membrane is over there, like that. So for the process of ultrafiltration to take place, the ultrafiltrate has got to go from the lumen of the capillary, through one of the fenestrations, through the small gap between the pedicels of the podocyte, through the filtration slit, and the filtration slits have this filtration membrane, has to go through there, and only then does it get into the glomerular space. Once it's in the glomerular space, straightforward, the fluid goes on down to enter the proximal tubule. So we have the podocyte, the pedicels, the filtration slits, and remember these filtration slits are only 40 nanometers. So from there to there is only 40 nanometers. giving the physical basis for this process of ultrafiltration.